Okay, click and close. Let's hit this real quick. Get you guys working on your own here for the last little bit. So click and close, phones away, etc., etc. Let's go through this. Got a few more to hit. Yes. Yeah, go quick. Okay, so this stuff, right? So we're talking about using a graph to solve an equation, right? So think what we got here. We've got the equation f of x equals 5. So we're going to, what's our strategy, right? If we're going to solve graphically, solve an equation, we graph everything, well, that's terrible color. We graph everything on the left side of the equation, so everything to the left of the equal sign. We set it equal to y and graph it. Well, that's the graph, right? This isn't one we can use Desmos for because we don't know what the function actually is. But they tell us it's graphed below. So there's a graph of y equals f of x. On the other side of the equation, we've got y equals 5. Well, y equals 5 is right there, horizontal line with the y-intercept of 5, correct? So then we end up with the point of intersection that has an x-coordinate of -1, right? Everybody agree? And so that's our answer. Now, on the test, you're not going to have this fancy horizontal line you can drag up to the problem, but in hindsight, did we really even need that line? No. I mean, what did it do? All it did was it allowed us to kind of visualize things, but our goal was to find the place on this function with a y-coordinate of 5. Well, that's the point, obviously, that has a y-coordinate of 5, isn't it?
Yes.
Right? So once we find that point, we're just looking for its x-coordinate, and that's the solution in this case, right? The example we looked at the other day was that one, a little harder one, right, where we used Desmos. Set the left side equal to y, set the right side equal to y, and then found the intersections. And the x-coordinates of the intersections were the solutions that we were looking for, right? Okay. If we move forward with that, I'm going to skip up just a little bit for a second up to these problems. Like here's one. We could use Desmos to solve, right? This is on the graphing calculator, the graphing utility, the Desmos part of the test, test number 2. All we do is we're just going to graph whatever's on the left of the equal sign we graph, whatever's to the right of the equal sign we graph, and we look for the intersection of the two. Agreed? And we want the x-coordinates of the intersection, okay? But let's get even a little more familiar with Desmos because there's some things about it that make this process easy if you know about them. So do we really even need to graph y equals 0? The answer is no, and I'll show you why. If I pull that graph up, there it is, okay? Everybody agree that's the graph? Well, trust me, that's the graph we were looking at, right? It was x squared plus 14x plus 43. We were trying to find where that equaled 0, right? If I go to this graph, and I'm going to go ahead and zoom out a little bit, I want you to notice something about this graph in Desmos. If I click on the function, if I try to click someplace up here, it'll tell me what that point is as I slide it along, what the coordinates are as I slide it along the function, but it doesn't stick, right? But notice what does happen. If I click on the graph, a bunch of light gray points show up on the function. In fact, if I zoom out more, I can even see more of those. Right? So let me zoom out some more here. Once again, if I click on the function, look at these things. I get these light blue points there, 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 and there. I got that just by clicking on the green function. So that's Desmos' way. So phone should be away right now. And what close that up for me too? So that's Desmos' way of communicating that, yeah, okay, you want some more information about this green function. Why are those points all important? What's so special about that one? It's a y-intercept, right? So Desmos predicts that you might want some, that's an important point on the function, so it makes it available to you. What about those two? What's significant about those two? Those are x-intercepts. Those are the ones that cross the x-axis, which is the y equals 0. I don't even need to graph that one. Those points already, it highlights those for me. And then the one at the bottom? Yeah, it's the vertex, is what we call it. The vertex of the parabola, right? Okay, so if I just go over and like click on those, for example, look what it does. They stick, because those are important points. And so I get the x coordinates, and so those are the solutions I'm looking for, aren't they? Everybody agree? Okay. So there they are, right? Negative 9.5 and negative 4.6. Okay. Oh, actually, negative 9.4, isn't it? Right? Negative 9.4, because it goes 9.44. So negative 9.4 and negative 5.6. Okay? Based on that graph. All right. How about this one? Okay? Same kind of deal, right? We've got everything on the left side is graphed in blue. Everything on the right side is graphed in red. Okay, and I've just got to find the points of intersection. Now, we talked about this one a little bit, didn't we, on Friday with you guys?
Yeah.
So remember, I had to tweak this thing quite a bit to get to where I could see those points of intersection, but I don't really need to, because once again, Desmos predicts that points of intersection are important points you might want to know about. So look what happens. I might have even done this on Friday, but I want to show it again, just to make sure everybody gets this. So when I first graph those two functions, that's what I see. Well, I've got to go down and maybe zoom out a little bit here, right, until I can start to see more interesting stuff going on. Okay. Now if I click on the red graph, look what happens. I can see some points down there. I'd have to zoom in maybe to see those more closely. But that's giving me two x-intercepts and a vertex, right? I don't really care about those for this problem though, do I? For this problem, I'm looking for intersections between the graphs. Well, what do you think those 2 points right there must be?
The points.
Those are the points of intersection, aren't they? If I click on the blue graph, notice what happens. Those 2 points stay the same, but the other points change, right? The other special points. So clearly, those are the two. If they're not x-intercepts or y-intercepts, and they're not a vertex, the only other possibility is they're points of intersection, right? So I don't even really have to be fancy enough to where I can show that those, what else could they be? They have to be points of intersection. And if I really want to prove it to myself, well then I could, I could just zoom in on one of those until I can see for myself that, oh, sure enough, okay, that's a point of intersection, right? And I could zoom in on this one if I want to, until I prove to myself that that one also. Well, I got to really zoom in, don't I?
Keep it going.
Oh my goodness. There, finally I'm starting to be able to see that that's a point of intersection, right?
Yes.
But did I need to do that? No, did not. Right? Didn't need to, because I could already tell that it had to be. Boy, I zoomed way in, didn't I? Holy smokes. My goodness. Right? I already knew that those two had to be points of intersection because they're nothing else. Get the idea?
Yeah.
Okay. Wow, I'm tired from all that zooming.
Yeah. Okay, Coach.
What's that?
Mesmerizing look at it zoom out.
Yeah. Maybe we'll do that again at the end. That was kind of tranquil.
Please don't.
All right, so please don't. Okay, so then this guy, here's another one we'll just quickly review. So if we've got a function and we want to do something with it on the test, you'll see one like this. So in this case, it's number of cell phones sold in a city is modeled by this function up here, right? We don't care that it's a polynomial, you know, that's a fancy word that we'll talk about later, but for now, it's just some function, we don't care, right? So N must stand for number probably, right? Number of cell phones, and what's X? Well, X represents the number of years after 2005. So all we want to do here is if we want to make a prediction of the number of phones in the year 2017, then we just got to figure out what value are we plugging in for X, right? To find the number of phones. So what number is that? Yeah, that just corresponds to X equals 12, doesn't it? So what do we do in Desmos? Row number 1, we just define the function, right? So here's the function. There it is, we got to put it in Desmos so it knows what to do. Step number 2, we're plugging 12 in for N, and this is the result. That's the output. So it wants us to round to the nearest phone. So 35555. Okay? Rounded to the nearest phone. That's how many cell phones that this model predicts will be in that city when X equals 12, which is 2017. Okay? Make sense? And then this guy. Okay, so here we've got a model that predicts yearly profit in millions. So once again, here's the function that we're going to use, right? So we've got to put that into Desmos, right? This time they want an average rate of change though. Well, average rate of change is just slope. It's always going to be y2 minus y1 over x2 minus x1 every time. That's an average rate of change, just means the slope between those points, right? Okay, but this isn't we don't have a graph here. And so we've got to rename those. So y2 is really just f of x2. Now in our case it's not f, it's p, right? So it'd be p of x2. And normally y1 would be f of x1, but for us it's going to be p of x1. So then we just need to know, well, what is x1 and x2? What are those numbers? And then we'll just plug those numbers into our formula, right? Well, let's go over and see. So once again, we're making a prediction based on the year. Well, x represents the number of years since the year 2010, right? And so 2013 is 3 years, would be x equals 3. 2018 would be x equals 8. Well, x1 would be the first, would be the earliest year, and x2 would be the latest year. So x1 is 3 and x2 is 8, right? We got it. So instead of y2, we've got p of 8, because x2 is 8. Instead of y2, we've got p of 3, because x1 is 3, right? And in Desmos, I saw a lot of people farting around trying to do these things individually. They wanted to find p of 8, and they wanted to find on one line, and then p of 3 on another line. And then they were going to go input those numbers manually and subtract them. Don't do that. Just do this, right? Desmos makes it easy. In Desmos, you just put all this stuff in at the same time, and it knows what to do with that because you already told it what p of x is, right? So we would just say for y2 minus y1, that's 8 minus 3. Well, x2 minus x1 is 8 minus 3, so y2 minus y1 is p of 8 minus p of 3. Okay? You get the idea? Okay, so that would be a good one to look at maybe tonight. Now, on these practice tests, just a quick reminder too about how you can use these as tools for your benefit to be most efficient. I can see where maybe there might be a time when you want to go through and do a complete practice test, just sort of see what you know and what you don't know. But now, at this point, wouldn't you agree that a lot of the stuff on the practice test you could probably look at and say, oh, I got that, I got that, I got that. But the few of them that you think you might need some extra practice on, what I would do is go in and just ignore the other ones and just do those. And you can keep reloading them if you want more practice. Like try one of these. If you get it the first try, then you're good. If you don't, well then, check your notes out and reload it again, right? Okay, last couple problems. This stuff. This will be quick. So I picked only the problems on the review that people had the most trouble with on the test the first time through. So these are the heavy hitters that everything else was pretty good. But these people had some trouble with. These transformations. So let's do these step by step because the order is important. So we're starting, g of x is going to be a transformation of f of x. The first thing we're going to do is we're going to vertically compress by a factor of 1/10. Okay, how do I do that?
Would it just be 1/10 f of x?
That's it. That's it, because really what that's telling us is that a equals 1/10, isn't it? Right? So then the yellow step is going to be, we're going to multiply out front by 1/10, right? Okay, what about the green step? If we're going to reflect vertically. Now let's remind ourselves how this works. If I've got some parent graph, we'll call that f of x. If I want to reflect it vertically, that means I'm reflecting over which axis? X-axis. Good. I'm going to reflect it down, whoops. I'm going to reflect it down to there, aren't I? So it looks like that. Okay, how do I do that? What did I do to f of x to create g of x then? Negative where?
Before the outline?
Before where?
Yeah.
Before the x. So I'm multiplying y, which is the whole thing, by -1, right? So I multiply outside by -1. Now what if I want to reflect horizontally? If I want to reflect horizontally, right, I'm reflecting over the y-axis, and I get something like that, right? And that would be, in that case, that would be, well, we're reflecting vertically here. So that would be like, we'll call it h of x. H of x equals f, where do I multiply this time?
Before the x.
Before the x. And here you can remind yourself why very easily. Because here I was exchanging y values. The y's became their opposites, right? So I had to multiply the whole thing, which is y, by -1. Here, only the x coordinates got switched. The y coordinates stayed the same, correct? So I'm multiplying just the x's by -1. Okay, which one is it here? Well, this one actually, we would have done this thing, wouldn't I? We would have reflected vertically. So in our problem, step 2, would have been there, right? Multiply inside. So this is our final answer, right there. Okay? How about this one? Same thing. We're starting off with some function f of x. First step is vertically stretched by a factor of 6. So what's that look like? So outside, good. Okay? Then we're going to reflect horizontally. Good. Because we're reflecting horizontally, we got to multiply over the y-axis, right? So we're going to multiply the x by -1 because we want to trade the x's for their opposites to make that reflection happen. Okay? How about this guy? Now this is a little different this time. Notice the difference. This time they tell us what f of x equals, right? So we're starting off with the function square root of x. That's our parent graph. We're only doing one thing this time. We're reflecting it over the y-axis. So is that a vertical or a horizontal? Horizontal, right? That was that one, wasn't it? Right? Horizontal. So what's the one thing we have to do then?
Times the x by -1.
There it is. Right? Okay, last one. We're going to do a couple things to this one. So we're starting off with an x squared function. Okay, first step, vertically compressed by 2/3. What do I do? Vertically, say it again.
2/3.
There you go. Multiply outside by 2/3. Multiply out in front, right? Next step. So that's really telling us A, isn't it? Right? That's telling us A equals 2/3. Next step. Translate 1 unit up. Say it again?
So put X parentheses, parentheses.
Like that?
X.
Oh, X, okay, so like, do that,
Yeah.
that close them,
Yeah.
okay, and then square it,
Good.
okay. Okay, and then where does this go? After, okay,
Outside.
so plus one, so that's really a value of K, isn't it? Right? Because that's the part that goes outside, okay? And honestly, okay, I can see why the parentheses got put there, but I really don't even need them right now, because I still don't have anything going on inside the function. Agreed? So I don't even really need them yet, but now I do. On this last step I do. Because now if I'm gonna translate 7 units left, okay, I'm subtracting 7, well, H is equal to -7, but H is what's subtracted from X. So you gotta be careful with this one. What's gonna go, that's the wrong color. I wanna do, I wonder if I can, this is tricky. I wonder if this works. I'm just playing with my toys here, never mind me. If I go. Oh, I need more. I don't want to waste time. So that's telling me H equals -7, right? And so my last step, my blue step. Okay, now what?
You have a phone call.
I have a phone call, but what do I have to do with that last step? Hey, Michelle. Yep. Oh, send them down? Oh, okay, bye. Bye. Jaden, grab all your stuff. So.
When is gonna be my?
Yeah. So what about here then? We get x plus 7. I get x minus -7, which is x plus 7. Remember this? It's been a while ago, but remember when we translate left, we're adding 7 to x. When we translate right, we're subtracting the amount that we're right. Remember that? So there's our answer. Right? This was such an expensive pen, I dropped my pen. We good? Okay?